Hi everyone, welcome back to Cody's Lab. So in this bucket is the liquid that is the result of adding dilute nitric acid to the silver gold alloy. So this liquid contains mostly silver nitrate, a little bit of copper nitrate, and a trace of palladium. And I think today I want to extract the silver. Now I've done this before, and I actually had it in this form as it is right now, and I just added some hydrochloric acid or salt to drop out the silver chloride, but I think this time I'm going to make the silver metal directly by using copper. So I'm melting down some scrap pieces of copper. Just give this a nice little stir, get all that melted. Okay, so now I'm going to take the copper, which should be liquid, I'm going to pour it out onto some sand, and hopefully that will create a nice long copper bar. Okay. Oh, it's heavy. Here goes. Oh, it's hot. Oh, I think that worked. A little bit of slag that poured out on top there. That can be brushed away. Awesome. So you can see I've transferred my silver solution into this glass cylinder right there. I've got a light on it to keep it warm and also generate convection currents, which will gently stir it. It's also to provide flicker-free lighting for my time-lapse camera here. I'm actually going to pour in just a little bit of water, mostly just to bring the level up a little bit more. Here's my copper bar. See, I've cleaned it up with a wire brush and drilled a hole up into the top. So you can see I've tied the copper bar to a glass rod, and I can use this to suspend the copper down into the solution. So here we go. You can see the reaction is happening almost immediately. Set that right there. Okay. Now what's going on is the copper, you can actually see some silver is flaking off of it. The silver is being replaced from solution by the copper. So it's going from silver nitrate to copper nitrate and silver metal. It's actually kind of cool to watch the silver crystals fall off. There's a little bit excess nitric acid in there, but there's also an excess of copper here, so I don't think we'll have a problem. See the silver forming on the outside of the copper? And since the silver is heavy, it kind of flakes off, exposing more copper. Avalanche! Oh, I shook the table. Oh, look at that. Oh, that silver just falling off. Okay, that's interesting. It seems for some reason the silver has been floating for this last little while. So instead of falling to the bottom, it's floated to the top. I see, it's just reacting with acid. It's producing gas. I guess as the dissolving capability of the water has been reached, and the nitrogen dioxide is starting to come out of solution a little bit faster. Oh yeah, I can even see that there's a little bit of an orange tinge above the liquid. Doesn't really affect the reaction much though, and I'm sure it'll settle down eventually. Yeah, you can see down in the silver powder on the bottom of the container that bubbles are forming. Yeah, the excess nitric acid is causing the silver to, some of it to dissolve back into solution and produce nitrogen dioxide or monoxide gas. At first that gas was just dissolving right into the water, being oxidized by dissolved oxygen. But now all the dissolved oxygen's used up. So it's just coming out of solution, almost like a fizzy drink. This will actually help because it's stirring the silver around, because every once in a while this will lift off and mix into the solution. So I guess one thing I could do is add some ammonia and neutralize the solution. That would work. It's unnecessary though. Alright, so it's been right around 6 hours. Let's have a look at this. You can see the crystals quite well right now. I think because the reaction rate is slowed down, the crystals are able to grow larger before breaking off. I'm actually a little bit worried about it bubbling over tonight. I might stir everything down. See, as the gas is released, you can see it reacts with the air, makes that brownish orange color. Alright, give this a nice good stir. You notice the solution is darker. It's got more copper in it. Now that I've released all that gas, the silver is able to settle. So I just give it a good strong stir. You can see most of the silver crystals are now on the bottom. Some of them are entrained in the mixture. You can see it's forming bands. It almost looks like Jupiter. It's kind of cool. And rather pretty. Let's see if I can zoom in on that. Yes. Silver crystals floating around in solution. I also moved the light farther away. Being that close, it was getting really hot. I think actually that's what those bubbles were. So I think all the acid is used up, but there is still some dissolved gas in there, and as the solution heated up, it's forcing it all out. So it's been 2 days since I started this. Looks like we got quite a bit of silver powder down at the bottom of the vessel. The solution is darkened. Looks like the silver's been sticking to the side, so it's really kind of hard to see in there. Looks like some condensation up top. Take that in. Pull this out to see how it looks. Yeah, it's a little bit smaller. Not a whole lot though. It's certainly lighter, but for the most part it's still there. It's like it's coated in a silver powdered mixture. So let's test the solution to see if there's any silver still dissolved. So let's drop in a little bit of hydrochloric acid. If there's silver, there should be a white precipitant forming. Like there is a little bit. You can see that. Maybe better from top. Yeah, so there is a little bit of silver chloride forming, so there's still silver in solution. That tells me it is not quite done. But it is definitely slowed down. You can see this is the amount of silver that has dropped off the bar today. So I've stirred up the solution again to release any trapped silver nitrate that was trapped down here in these silver crystals. I've also decided to give the copper bar a good scrubbing to remove any of that contaminants that are blocking the silver from reacting with the metal directly. A lot of this is actually silver, but it might be copper oxide and anything else that was in there preventing the silver from reacting. So let's scrub that off. See, now the copper bar is clean again. You can actually see there's some crystals showing up in the copper. See that? It's very nicely etched. Let's see if anything else comes out of the solution tonight. Oh, it didn't immediately tarnish, so tells me the silver is definitely pretty low. So we're coming up on 3 days since starting this copper bar into the solution. Last night I actually took it out and scrubbed it to remove any silver that is stuck to it or any other impurities It looks like it's tarnished yet again, but there's certainly not any large amounts of silver falling off, so I'm pretty sure this is pretty much done. Let's let that drip for a second there. Okay, let's just lay it down on the table. Now, just to check to make sure we've got all the silver out of the solution, I'm going to add just a little bit of hydrochloric acid. Oh yeah, that is not producing any silver chloride, so I'd say our solution has been depleted of all the silver, or at least enough that it's not worth recovering it anymore. Alright, so I've got this siphon pump with the lead going down into a bucket. We're going to siphon out the copper nitrate solution. So just give this a little bit of a push, and down it goes. Alright, so I'll just kind of slowly siphon this so I don't disturb the silver powder that's down in there. So this copper bar, it does weigh a little bit less now because of course the copper was used up. It is now into the solution. But since copper has about half the molecular weight of silver, and also silver nitrate is a 1 electron transferred, whereas copper is 2. The amount of copper that actually was used up in order to replace all that silver was very little. I figured that for the 800 grams of silver, it should take maybe 230 grams of copper. So this bar is almost the same shape and size as when we started. But yeah, I can tell that it is lighter. It's about ½ pound lighter. So, incidentally, that's also why we don't use copper to Inquart. It takes way more acid. Alright, so that's as much as I could siphon out. So now I'm going to have to add water in order to get this remaining amount of copper. In case you're wondering what I'm doing with the copper, I will be recovering the copper eventually. But for now, I'm converting it into copper carbonate by adding it to this bucket with some baking soda. Baking soda reacts to form copper carbonate and sodium nitrate. You can see that I already had a bunch of copper from some previous processes down in there. So, you know, it's not really going to be worth my time to recover the copper until I've got a large amount of it saved up. So there you go. And there should be enough excess baking soda in there to react that and form copper carbonate. And I've been letting the water just evaporate, but I might end up having to siphon the water off this time because there's just so much of it. Actually, I decided running it through a filter would be faster and save water. Alright, let's pull this all out of the filter here. I was just using a shirt, by the way. Looks like a lot of silver got stuck in it, so I might have to wash it out. Yeah, maybe not such a good idea then. So this is the silver that was stuck to the shirt. I just washed it off with some water and I just got through filtering it out. So now I'll just go add this to the rest of it. So here's the silver powder completely dry. You see there's the filter paper. I'm just going to put that into the crucible along with the silver. It'll help protect from oxygen. Let's just transfer this over, and then we can melt it down. Alright, we're ready. Brilliant. See that? Alrighty. Let's pour in the silver into my preheated mold. Perfect. Figure out why my furnace quit. There it is. This is cooled off. Oof. Next bunch of silver. Okay, that was a little bit fuller. We're going to put this up there. In case you're wondering, that blue flame you see is actually the carbon burning. Looks like it didn't oxidize too much. Doesn't have that much copper in there. Anyway, let's go cool these off and see how much we got. Okay, so here they are, all cooled off. Let's get their weight. So 392.5. Let's add that to 444.69. And this bit of silver that splattered out on the table, which I remelted down, another 34.75 grams. Alright, that comes to 871.94. Now, I added 800 grams of silver, or more specifically 800 grams of sterling silver, which is 0.2925. So, 800 times 0.925, so that's only 740 grams of silver that I added. This isn't pure silver, but it's probably a lot more pure than the original sterling. So, where'd the other silver come from? Well, it came from the jewelry itself. So I gained another, let's see, what was that? So I managed to gain about 130 grams of silver from the jewelry itself. It was probably around $75 worth, so yeah, it's not insignificant. Of course, I don't know how much palladium's in here yet. Probably not that much. And there we have it. There's the silver we used to inquart the gold, now recovered. It's about $500 in silver right there. Now, it isn't super pure, so I probably couldn't sell it like this. I'm planning on reusing this to add to gold again, so I wasn't really too worried about it. Look, they're growing. So a lot of people were very upset about me releasing the numbers of how much I paid for the jewelry on Patreon and not releasing it publicly. The main reason I did that is actually I don't quite yet know how much I made or if it'll be profitable to buy jewelry on eBay and refine it. So I'm mostly keeping it behind a paywall until I know for sure. I don't want a whole crowd of people, storming through eBay and then finding out that I wasn't able to make money, right? So, anyway, hope you enjoyed. I'll see you next time.